OK, so now that we know the definitions of how the web works and how we make web pages look good, we can think about the various security risks we have to be aware of when it comes to the web. So there's a couple of risks we'll think about. Let's go through them one by one. The first one is that the web server itself should be protected against malicious access. So an attacker shouldn't be able to hack into the web server and serve malicious results to users. So remember that the web is a bunch of browsers and servers. It's a bunch of machines sitting in different places. And the servers are responsible for providing data to users who request it. So those servers that are providing data should be secured. An attacker shouldn't be able to hack into those servers and give users malicious data. Now, the way to protect against this is the same way you would protect against any other piece of software or any other system that you design. So for example, use a memory-safe language, turn on your buffer overflow defenses, use secure passwords, don't give a user too much privilege. All of the usual things that we're already doing to keep our system secure also apply to web servers because we have to make sure that the servers aren't hacked into. So it's less of a problem with the web specifically and more of a problem with the servers that are serving content on the web. So that's all we'll say about this particular risk, since most of the fixes have to do with keeping your system secure. Now, the second risk is that you might visit a malicious website. So as we've talked about the web, we haven't put any restrictions on who is allowed to be a server. And in fact, anyone can be a server. So the attacker themselves could register a domain name like evil.com, and now anybody can access the attacker's server, and the attacker can serve malicious files or malicious data to users who visit their website. So there is no restriction on who can be a server, and if an attacker is a server and you visit the attacker's website for some reason, then the attacker is free to send you whatever they want. They could send you malicious code, they could send you a virus, they could send you malicious data, and all bets are off in that case. However, it would be pretty bad if someone who accidentally visited this evil.com website had their entire computer bricked. So for example, the files all get deleted, or the attacker steals the user's password. That would be pretty dangerous. So modern browsers try to protect against malicious websites by heavily sandboxing the browser. And if you remember the word sandboxing from a while ago, it means running programs in a protected environment so that even if the program is malicious, it doesn't have access to your sensitive data, like your passwords or other files on your computer. So browsers are heavily sandboxed in this way. If you visit evil.com and evil.com sends you back some JavaScript that runs in your browser, even if that JavaScript is malicious, the browser ensures that it can only access your browser, and it can't access, for example, the files on your computer, or the password in your computer, or the code of your operating system. All of that is protected against the malicious code. It's not allowed to access those sensitive things because the malicious code is running in a sandbox. And this relates to the least privilege security principle that we talked about. We said, don't give code more permissions than it needs. In this case, the JavaScript should only affect the website that you're loading. It shouldn't be able to go and change the code of your operating system. And to make sure that this is true, we have to be very careful with our web browsers. So if you're someone who's programming, say, Google Chrome, you're working at Google, and you're writing the web browser itself, then you have to be very careful to make sure that you're running that JavaScript in a protected sandbox, and you're not creating vulnerabilities in the code of the browser itself to allow attackers to break out of the sandbox. That's mainly relevant if you're the person developing the web browser, but modern web browsers are pretty good at sandboxing and preventing evil websites from doing more damage than outside of your browser. And the third risk that we'll talk about is websites affecting other websites. So it could be the case that maybe you have two browser windows open, or you have two tabs open. In one tab, you've loaded your bank account, and it has your bank information, it has your password. And in the other tab, you log on to evil.com. You visit the attacker's website. Now, both of these are in your browser, so it would be pretty bad if the evil.com website was able to hop over to the other tab that you have open and steal all of your bank account data. It would also be very bad if the evil.com website could switch over to a different tab that you have open and read your emails or open your Amazon account and buy things. We don't want these two websites to interact with each other. So another risk is not the malicious code breaking out of the sandbox, but the malicious code in your browser affecting other websites that you're visiting. That would be bad. And to fix this, we'll add something called the same origin policy to stop unrelated websites from accessing each other's resources, because that's a security risk that we have to deal with.